Okay, today two things, surface area and volume of spheres. You ready? First things first, how do you draw a sphere? Nathan?
Draw one big old circle and then draw
One big old circle coming up. There you go.
and then you draw a dotted line going through the middle to make it look like there's two half circles together.
Think I understand what you're talking about. Are you referring to something like this?
Yes.
Beautiful. We give that three-dimensional feel there by drawing that equator line. Okay, hot diggity. So there's a sphere. One thing we haven't addressed, however, is the simple question, what is a sphere? Connie, what do you think? You've done an excellent job in writing some of our definitions,
So it's
and you're wearing a very cool Red Hot Chili Pepper shirt today.
so it's a three-dimensional shape
I like it.
where the distance from the center to any point on the outside is equal.
I like it. You want to embellish more, or are you happy with that?
I think that's good enough. I mean, I can't think of anything else that would meet the same criteria.
Shall we question the masses?
Sure.
How's this definition?
Pretty good.
Pretty good? Can we do better?
No.
No.
No. So therefore, how's his definition?
Perfect.
Amazing.
Yeah. Darn tootin'. All right, give it to me again.
A three-dimensional figure where the distance from the center to any of the
How fast do you think I can write? Where the distance, yeah,
from the center
from, let's call that, we'll say it fancy, like from a given point called the center,
to any point on the outside of the figure
to any point on the outside of the figure?
No, like the on the shape.
Okay, how about on the figure?
Yeah,
Mm-hmm.
is equivalent.
Is equivalent. Was that a bell?
Somebody dropped their Chrome.
Job opening.
Job opening?
Yeah, that's what you say whenever like you hear something break, like especially at a restaurant. I don't know.
Oh, I
that's,
get it.
That's
They
what my
broke it, yeah.
well, my dad used to work at a restaurant, so I think
Gotcha,
it's just
yeah. You break something, you get fired.
Yeah.
Yeah, so there'd be, that's pretty fun. Good. Well done. Yeah, looks like I picked the right person. Let's go back to the discussion of cross sections then. If we slice a sphere, what kind of cross section do we get? Circle, right? So there's a circle. What if I don't slice it through the center? Still a circle. No matter how you slice a sphere, the shape that you get will always be a circle. So if I slice this edge up here at an angle like that, we're still going to get a circle. So again, no matter how you slice it, it's going to be a circle. But you notice, however, that those circles will be of different shapes. Sorry, wrong statement. Those circles will be of different size. They're all going to be the same shape. That shape is a circle. Duh. The ones that pass through the center of the sphere are what's called great circles. Okay, so again, great circles are cross sections that pass through the center of the sphere. Those are incredibly important because they're for a couple reasons. Number one, they're the largest circle that you can get as a cross section. But number two, the reason they're so important is because if you pick any 2 points on a sphere, the great circle represents the shortest distance between those 2 points. So let's say, for instance, you're flying from Chicago to London. Anybody ever flown from Chicago to London?
yeah.
Okay. You would think you would go straight the east. You would think you just leave Chicago and go straight east because London is almost directly east from us. That's not the case. You actually go north a little bit. You travel along the great circle. So when you fly, you open the back of the magazine and they've got all the red lines that show you how they fly to all the different locations. Those lines are actually along great circles. Okay, so if I'm flying from Chicago to London, it would seem like you would just go due east, but you don't. You actually curve northward because you want to be on, that's a horrible drawing. As you can clearly see that great circle, you want to be along the great circle. And so when they plot flight paths for planes, they try to always have those planes fly along the great circle because it is a shorter distance, saving fuel, saving money, all that other fun stuff. Okay, that's your fast fact for today. It has virtually no relevance for us other than the fact of what a great circle is. Get this out of the way. Everybody's seeing all kinds of stuff here. Just out of control. Gesundheit. 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 Ooh, hat trick. At least you got the hat trick in there. That's good. Okay, so great circles. We got that. And there's no fancy way to derive the surface area and volume formulas for spheres because most of these derivations come from calculus, so I'm just going to give them to you. The surface area of a sphere is 4 pi r squared. Remember, surface area is in square units, so therefore the r is squared. The volume, oh, by the way, how many variables in this equation? 2. And you should be able to work in either direction. If I give you the surface area, find the radius, give you the radius, find the surface area. Is it safe to assume that you can do that?
Yeah.
Awesome. Volume. 4/3 pi r cubed. This one's not so easy to work with. So we're going to do a couple examples using that. Volume are cubic units, so you have to remember to cube r. People screw these formulas up all the time. Question in the back, sir.
So for surface area, why is it 4 and volume is 4/3? Any specific reason? Like you fit 4 circles in a sphere, or like 4/3, whatever.
I'll give you the simplistic version with no explanation. The surface area is the derivative of the volume. Calculus.
Yeah.
Okay. It's generated by taking a hemisphere and revolving it around an axis and integrating the circles that are created when you do that.
Oh.
You'll learn about it. It'll be fun. Okay, so this one we're safe with. Let's take a look at this one. Next screen. That's an N. Faith, you're always fun to pick on. What do you think the volume of a regulation NBA basketball is? Well, you know what a basketball is, right?
Yeah, but I don't know.
Okay, so what do you think the
I know
volume is?
basketball.
What units would you like to work in? Cubic inches, cubic feet, cubic yards,
inches.
cubic miles, cubic centimeters, cubic inches. Okay, how many cubic inches do you think are in a regulation NBA basketball? Basketball is about that big.
12?
Okay. Excellent guess. Erica, what do you think?
I don't know.
No cheating, by the way. Stay off those iPads. Nathan. Weasel. What do you got?
16.
16? Getting all crazy. Kaylin, what do you think? 24. Everybody likes the even numbers. Veranch? 21. You just chose a not answer because I said that, right? Okay.
I don't know the actual.
I understand. So we'll leave this here. Then we'll go to USTA. United States Tennis Association. I don't even know if that's a real organization. I just made it up. Camilla, what do you think the radius of a regulation tennis ball is?
Like an inch.
Natalie, what do you think?
3 inches?
3 inches. Anybody play tennis? No one's a tennis. You're a tennis player? Do you know?
I was thinking 3 inches
You're gonna go with 3, so we'll put 2 checks there. Anybody else? The radius of a tennis ball, yes.
2.5.
2.5 inches.
2.5.
Anybody else? Yes, sir. 2. Anybody else? By the way, if you have it, we're then gonna vote and take a tally. So you have to vote for one of these or you have to give me a different number. Nathan?
The radius, like 1.5.
Anybody else?
Hey, can we go back to the NBA one first?
No,
Oh,
not yet. We will. Can you hold it for a second?
okay, yeah.
Okay, good. Did you have a comment or question?
I wanted to ask.
You wanna guess?
Yeah.
Did you cheat and look it up?
No.
Okay, good. All right, how many think it's 1 inch? Raise your hand. Well, there's gotta be at least one of you. Who told me 1 inch? Come on.
I changed my answer.
Changing your answer. 1 inch goes away. 3 inches. 1, 2, 3.
Oh, oh.
2, 4. 2.5 inches. 1, 2, 3, 4. 2 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1.5 inches.
How big do you guys think it
4, 8, 17,
2
18.
inches.
Somebody didn't vote.
Yeah, it's like
That's the radius.
Who didn't vote? Nick, did you vote?
Yeah. I changed my answer. I switched from 2.5 to 2.
So you voted twice.
No,
No,
okay,
he
no, can
wants
I?
to.
Can
2.5
Can you? No, not now.
Okay.
All right, regardless of which one you voted for, calculate the volume. I'll wait.
Of the one you voted for?
Yeah, the one you voted for.
doing tennis balls and basketball, or just?
Nope, just tennis balls first. And then once you get your answer, check with the, like if you voted for 3, once you get your answer, check with the other 3s. If you got a 2.5, if you're the 1.5 person, you check with yourself to make sure you got the same answer.
Is it 2.5? 26.4.
I'll read it. Yeah.
27.18.
Okay, who's my 3.0 representative? What do you got? Come on, don't be bashful, let's go. 3? What's the volume? Oh, for God's sake, somebody answer the question, you babies. What's the volume if the radius is 3? Natalie, thank you.
36
Which is approximately, can you multiply that out for me?
113.09.
2.5, yes.
65.45.
Huh, look at that, a half-inch difference in the radius causes that much of a variation. 2? Uh-huh.
I think it's 33.51. Tell me if I'm wrong.
You're right.
Close enough. And 1.5?
9.42.
Somebody get on the Google. What's the volume of a tennis ball? Hmm? You want it to be 40?
Yeah.
Aren't you on it?
Just get on that number.
That's to be like 9 point something.
6 point, oh wait, that's the diameter, is 6.5 centimeters.
We want to know the, yeah, it's
This is the
centimeters.
diameter is like 2.5.
Inches?
Yeah.
Oh, the diameter.
See, this
I-
one's,
I- I
oh,
Googled-
so you
I
have
said
centimeters
I accidentally typed in volume of a tennis and then that was what came up. Oh, it says 8 cubic inches.
Oh, yeah. I see.
Volume of tennis ball, 8 cubic inches.
Yes.
Oh,
That just was the answer.
interesting. Maybe you should have stayed with your original answer.
Yeah.
Alright. So let's work backwards with the basket, yes?
Wait, are we trying to do volume for the?
That's volume, this is radius.
Yeah, I got it.
Go ahead.
I want, I don't know. I want to say like,
Go for it.
hang on,
Go ahead.
like 424 inches.
Cube.
Yeah. Isn't it the volume?
You want to go from here and you want to jump up to 424.
Okay, because it's the volume, and a basketball is way bigger than.
I'm just asking. You want to take all these answers that have already been answered and you want to say 424.
It just, I feel it. I can feel it.
This will be
It's
interesting.
volume, right?
It is volume, that's the question. Before we do the, what time's the bell ring, by the way? What time?
53.
Oh, we got time. Okay. Let's do a simpler calculation before we work with the basketball. Let's take a look at this. Suppose you have something that has a volume, a sphere that has a volume of 100 pi. What's the radius? Okay, so volume is 4/3 pi r cubed. So 100 pi equals 4/3 pi r cubed. What do I do first?
Cancel the pi.
Cancel the pi's. What next? Okay. Multiply each side by 3/4, which gives me 75 is equal to r cubed. How do I undo the cube? Cube root it. Where's the cube root, Johnny?
Math 4.
Attaboy. Go to math 4 on your calculator. Take the cubic root of 75,
4.22.
and we get the radius being 4.22.
Because I was trying to find like that.
Okay, so now we look at the basketball. Let's pick one randomly. Let's do 24.
Wait, can we add
Can we
one?
still add
Wait,
Yeah.
'cause that one's not-
You want to add another one?
Yeah.
Why? You start doing some calculations?
Just what I think.
All right, George?
381.
381.
1083.
1083.
Can I change mine?
Nope.
Oh,
You already committed.
For volume or like for the diameter?
Those are
that's what we
a diameter of 381 inches?
Oh my
No.
god.
That'd be a-
The 12, 64, 21.
I would agree.
That'd be a big old basketball.
I wanna go with 50.
Let's pick 24 and work backwards. 24 is equal to 4/3 pi r cubed. There's no pi to cancel, so what do I do first? Go ahead.
Divide by 4/3 pi. Or you could just multiply both sides by 3. Or just
There's a lot of different ways you can do it. The way I would do it, question? Answer? Or just relax?
Just relax.
I understand. I would take 24 divided by pi, hit enter, then take that answer and multiply it by 3, hit enter, then take that answer and divide it by 4. Or you could take 4 divided by 3, enter, times pi, enter, then type in 24 divided by the answer. There's a lot of different ways you can do it. Regardless, when you do it, you get the r cubed value being, yeah. Everything on my own here. 24 divided by 5.73. Math 4 of the answer gives me a radius of 1.79 inches. Probably off a little bit. Just a little. So that answer would eliminate this, 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 and this, because those are not going to be big enough.
24.
Veronica, do me a favor. Could you look up the radius of a NBA basketball? Okay, so if the radius is 5 inches, right? Yeah. If the radius is 5, what's the volume?
455.5. Something like that.
Did you just do that in your head?
Yeah.
No, I Googled it.
You Googled that if the radius is 5, what's the volume of the sphere?
No, I Googled the volume. I don't know, like,
No, it's not.
they're both right. Like, one might be, like, wrong.
If the radius.
So in other words, you didn't do the math, you used Google to find the volume of a basketball.
Yeah.
Well, that's not the question I asked.
Yeah, I know.
Yeah.
If the radius is 5, the volume is 523.59.
Inches cubed. Okay. How many tennis balls will fit in a basketball? Now that question can be answered in 2 different ways. That question could be intended to be asked, how many tennis balls could you physically jam inside a basketball? Which is a very difficult question to figure out, requires some engineering and a bunch of complicated math. But I'm speaking volume-wise, how many tennis balls would fit inside a basketball? What did we have for the volume of the tennis ball? Everybody write that down.
Yeah.
What was it?
8.
8. So what's 523.59 divided by 8? 65. So approximately 65 tennis balls will fit inside a basketball, volume-wise. Next question. How would you figure out how much rubber is used to make a basketball?
Finding the surface area.
That would tell you how much is on the outside, but it won't tell you how much actual rubber is used to make that.
So
Johnny?
So you take the volume, and then you take so you find, like, the depth of the rubber, and then,
The thickness?
yeah.
Uh-huh.
And then you take the area of, like, the ball that's not,
Careful what words you're using.
take the volume of the amount of the basketball that is inside that's not rubber.
That would be known as air.
Yeah.
Yeah.
And then subtract that from the ball.
Did that make any sense to you? Did you get that?
Yeah.
It's the volume of the outside of the basketball minus the volume of the air inside. How do we find that? Well, we need to know how thick a basketball is. Visually, what he's talking about is saying, in essence, we have a sphere within a sphere. So here's the basketball. Wow. That's, yeah, it doesn't bounce so well. Well, it's okay until you hit it on the flat spot, then it just makes a thud. There's the outside of the basketball, and then, I don't know if I can draw this. There's the thickness of the rubber used to make the basketball. So let's suppose, well, we know this already. What did we have the radius of the basketball being? 5? Varanch?
Yeah.
What's the thickness of a basketball? Hurry, the ball's gonna ring. .125 so that is 0.125 inches. Therefore, real quick before you go, what's that radius?
6.2.
No.
Oh, rated. Oh. 4.8275.
4.875.
75.
So using Johnny's method, then we would find the volume of the basketball with a radius of 5, then find the volume of the air, subtract the 2, have a nice day. Quiz tomorrow. Woohoo!
What did you quiz on this?
Possibly. Anything is fair game. Quit your whining.